Alright, so in this section we're going to look at how to graph linear equations using the x and y intercept. So first we're going to look at what is the x-intercept and what is the y-intercept of an equation or of a graph. So if you look at this graph here, we have, if you look at the y-axis, so here's my y-axis and here's my x-axis, and here's my graph. Now where this graph crosses the y-axis here, this point here, that's what we call the y-intercept. So where it crosses the y-axis is called the y-intercept. Graph crosses the x-axis, so in this other point here, let me erase this real quick, there. So where it crosses the x-axis here, that's called the x-intercept. So the point where the graph crosses the x-axis is called the x-intercept. Let's undo that. Alright, so if we look at the graph here for the x-intercept, again, it's this point where it's crossing the x-axis. And so if we write down the coordinates, we have that has x-coordinate 1, negative 1, sorry, and y is 0. And for the y-intercept, if we look at the point where it crosses the y-axis, the x-coordinate there is 0, and the y-coordinate is 1. So again, where it crosses the y-axis is the y-intercept, and where it crosses the x-axis is the x-intercept. If we look at this example down here, notice that this graph crosses the x-axis twice, here and here. So we would have two x-intercepts. So the x-intercept on the left here crosses at negative 2, 0. And the other x-intercept is this one here at 2, 0. So your graph can have multiple x-intercepts or y-intercepts. It just depends on what it looks like. And here it looks like the y, or at the y-axis, this graph crosses it at 0, negative 2. Alright, so that's how we identify the x-intercepts and the y-intercepts if we had the graph. Now let's suppose I wanted to use these x and y-intercepts to graph a line or one of our lines. So let's consider what the coordinates should be. This is, if you look at all the points that would be on the x-axis, for example, so say like this point right here. If I put a point there, notice that the coordinates would be 1, 0. And let's suppose I was looking at this point, that would be 5, 0. And let's pick this guy here. If it was on the x-axis, notice that it would be negative 3, 0. And what we want to notice is that the y, notice the y's, because to be on the x-axis, these y's would always have to be 0. So if you're trying to find where the graph crosses the x-axis, then your x-intercepts have y values of 0. So if you're trying to find these guys, always look to see when y is 0. Now, on the other side, let me clear this. If you're talking about y-intercepts, again, if I have a point on the y-axis, say here, the coordinates would be 0, 1. And if I had a point here, that would be 0, 3, and so on. Even a negative 1 down here, 0, negative 2. Now, notice that now instead of the y's being 0, if you're on the y-axis, your x has to be 0. Otherwise, you're going to move either left or right. So if you want to find the y-intercepts, always look to see where x is 0. So if you're finding the y-intercepts, look at the x values when x is 0. If you're finding the x-intercepts, look for the y values where the y values are 0. And so we have this linear equation, negative x plus 2y equals 6. Now we're going to use the x and y intercepts of the graph of this equation to actually graph the equation. And so what we have to note, if we're trying to graph this to find by using the x and y intercept, well, first we got to find the x-intercept, and I'm actually going to use a table to keep track. But I do have to find first the x-intercept, so let me go through the steps finding the x-intercept of this graph. So we're using the conclusion that if you're trying to find x-intercepts, again, the y has to be 0. And so I purposely set y equal to 0. So it's like finding the order pair 0, comma, blank, right? Because I want to see those points where y is equal to 0. So I take my equation, and just like we did in the last section, replace the 0 for my y. And I just then simply work out this equation. Let me divide by -1. So this becomes -6. So then I can complete my order pair. X is -6 when y is 0. And so let's see, that would be this point here, -6, comma, 0. And if I want to put it on my table, it looks like this, -6, comma, 0. So that's step number 1, find the x-intercept. And let's see, now we're going to find the y-intercept. Of this line. So again, now remember, to find the y-intercept, x has to be 0, and so I purposely again find out when x is 0. So, and what I'm trying to complete is this order pair now, 0, comma, blank. So just like before, I'll go to my equation, replace my x with 0, and solve the resulting equation. So that here will be 0 plus 2y is 2y equal to 6. Then divide by 2, and y is equal to 3. So then my y-intercept is, remember, x is 0, comma, 3. Remember, we were trying to complete this order pair. So if I put it on my table, it would be 0, comma, 3. And so let me graph that. So 0 for my x, and there is my y-intercept. Crosses the y-axis here, and it crosses the x-axis there. Now to play it safe, just like the other examples, you can do a third point to check that you have the correct points there. But otherwise, we can see that our line is going to cross those intercepts there, and there is our line. So again, if the instructions are to graph by finding the x and y intercept, you first find the x-intercept and then find the y-intercept. We graph each one, and we connect our points with our line. And that's how we do graphing using the x and y intercept. So it's kind of, if you organize it back in the table, it's kind of like still using a table, but you are restricted to using 0 for y to find the x-intercept, and that one. And then you also have to use 0 for x to find the y-intercept. And there you are. Now, so let's look at a different example. So, again, if you wanted to organize it on a table, so you have x and y, and so you want to find both the x and the y-intercept. So we'll start out with the x-intercept. So your table, it's going to look like this. So the x-intercept, so when y is 0, that's the first thing I'll have to find. And the next thing is the y-intercept, so I'll set x equal to 0 for the y-intercept. Alright, so we'll start with those two. So again, now if you put it in table form, it's kind of like what we did last time, but it's nice to label them separately so that you know which one you're finding. So again, we're going to find the x-intercept first, set y equal to 0, like it's not x, so y is 0, and negative 2x on this side. So divide both sides by negative 2 to find this x, and you see that x is 0. So it just so happens that 0 is also the coordinate of this x-intercept. And let's see what happens with the y-intercept. Actually, before I actually find it, let me actually graph the x-intercept. So 0, 0 would be here. So there's 1 point. Now for the other one, we're going to set x equal to 0. And so if I do that, so now that's this one, I have this equation. And when I multiply those two, I get 0. And so you see that if x is 0, then y also is 0. And when I go to graph it, notice that it's already there. It's my point that I already have there. Now this will happen every time if if you have the order pair 0, 0 on your graph, it's going to, for lines, it means that both the x and the y-intercept are exactly the same. So they're the same point. And we know that we can't graph a line with 1 point, so generally we use 3 to be safe to check, but for equations where this happens, we actually do have to use a 3rd point to actually get a line, because otherwise we just have 1 point. So I'm just going to randomly pick 1 and find out what y is when x is equal to 1. So I'll replace x with 1 and get that y is equal to negative 2. So I do, in this case, get this third 1 comma negative 2 point. Right, negative 2 is the y coordinate for my third point that I use to graph this line. 1 comma negative 2, and there you are. Now I have 2 points so that I can graph this line. Let me see if I can do my best to connect the dots. Hopefully your graph is a lot nicer than mine. Let me do this real quick. There we go. There we go. And there you are. We use the x and y intercepts to graph. Alright, let me see. Let me pause here for a second. Alright, so for this part of the section, we're going to look at how to graph horizontal lines. Now, we're actually going to use a table, just like we've been using. So let me draw a table. Here's my x, here's my y. Just like before, like we did with tables, I'm going to pick a couple of random x values, so say 0, 1, and 2. Now notice here in the equation there is no x to plug in, say my 0 anywhere, but in order pair to be a solution of this equation, the y has to equal 5, so that when I replace the 5 into the y, I get 5 equals 5. So what happens is that x really doesn't affect what the y coordinate is, because y always has to be 5. So if x is 0, y is 5. So if I plot that, 0, 5 is here. And then again, if x is 1, y still has to be 5, so that when I plug it in, to the equation, I still have a solution, so it'll be 1 comma 5, and then finally 2, and y has to be 5, so that when I plug it in, I get a true statement. So then 2 comma 5. And you can see I have my points are in line, and what I end up with is a horizontal line. And it's a horizontal line that passes through 5. So what will happen every time you end up with an equation that doesn't have a variable x, even if there's stuff around the y, like plus or something like that, once you isolate the y or get the y by itself, you'll see that the y always is restricted now to always be in 5. And so if that's the case, if y is always the same, you do end up with this horizontal line. And so in general, y equals, say, a number b is a horizontal line crossing the y-axis at 0 comma b. In other words, it's going to cross here, the y-axis, when you have a horizontal line. Alright, and that's how horizontal lines work. So in general, and so if you'll have the graph, if you graph it, and so if here's b, then your horizontal line is going to cross the y-axis at b, or 0 comma b. Now for vertical lines, we're going to take the same approach, and we're going to once again use the table to explore on how to graph these lines. Unlike the horizontal lines, notice that the y is now missing from my equation. So now I'm restricted to always using x equals -3, because if I don't, then when I replace the x by that number, it won't equal -3. And so that's why my first point has to have x equals -3. Now to find the y, like we did before, notice that there is no y value here, so that the y value can be whatever you want. So let's say -3, 0. And if I plug in -3 for x, I still true, so that the 0 doesn't really play a role in checking. And so -3, 0 is a point on my line. And again, my next point also has to have x coordinate -3, so that's a solution of that. Let's say -3, 2. So -3, 2 would be here. And let's just do one more. -3, 1. -3, 1 would be there. And if you keep selecting values, because x is always the same, you end up with this vertical line passing through x equals -3 for the, or by the x-axis. And so, similar to when you have horizontal lines, if you in general have a linear equation that looks like x equals, say, a, here where a is real, so it's a real number, then this is a vertical line crossing the x-axis at a comma 0. So the graph would look like something like this. So my y, my x, and say a was here, and that would be my vertical line crossing the x-axis at a. And so again, table-wise, all the x's are the same, and on the graph, what you can see is that you have a vertical line passing through that value.